Sometimes we want to have very direct, explicit control over the behavior of our RBD sim, and we don't just want to rely on the built-in DOP nodes to do this for us. Sometimes things will be much more direct and controllable if we explicitly set it up in a geometry wrangle. Now, the most common case where I use a geometry wrangle for this sort of thing is when I'm setting up a custom drag. And I'll just copy our initial velocity demo to create a custom drag demo as well. So you can just duplicate that, call that custom drag, and dive inside. Now, the reason that I often set up a custom drag force is because if we look at the normal drag DOP that's available in our DOPnet, this will scale down our torque and our linear force, but when we want something to be really explosive, we might want it to fly very quickly for a couple frames, and then for a handful more frames, we want that to be scaled down in velocity, and then we want the sim to really take over in a more natural way. And I also often want my drag to affect X and Z, but I might only want it to affect Y if the piece is going upwards. Now, because we're going to be setting up this very strong custom drag for a very explosive scenario, and we're going to be scaling down the velocity very quickly, I'm going to multiply up the velocity by quite a bit on this V from point that we set up previously. I'm going to change this multiplier to 100, and then we can go back to our DOPnet, and we'll have to change how this is wired up a little bit in order to use our geometry wrangle that you can drop down next to your bullet solver. We're going to use a multi-solver to mix the bullet evaluation and the geometry wrangle evaluation. So create a multiple solver as well, and we'll connect our RBD packed objects to that instead of connecting them to the bullet solver. And we'll take that bullet solver's output and connect that to the multi-solver instead. And now we can wire both the bullet solver and this geometry wrangle into our multi-solver. Now, this geometry wrangle is very powerful because it gives you direct access to set various attributes on your RBD geometry in the middle of the simulation. So for a basic example, we could do a simple check to see if the frame is greater than 990. And if it is, then we can scale the velocity down to 0. So I'll type if at frame is greater than 990, then v at v times equals 0. Now, if we flipbook this simulation with that geometry wrangle applied, you can see that it's clamping our velocities to 0 after frame 990. We're still getting a lot of spin because we still have angular velocity on the pieces. If you want to, you could also multiply w down to 0 if you want to stop the spin as well. But you can see how powerful this geometry wrangle is because we can explicitly define the behavior of our simulation instead of just relying on the sim to hopefully do what we want. Now, instead of multiplying our velocity down to 0 once the frame is greater than 990, we can enter this VEX code instead. And this is a bit more extensive than the previous bits of VEX that we've looked at so far. But even if you don't have much programming experience, you can control the effect just by changing the drag start and drag duration values and the multiplier values down here, just at the end of that statement. To help describe what this code is doing, I'll bring back my simple little drag sketch here. And this drag start means that this is going to wait until a couple frames after the activation before it starts applying the drag. In this case, it'll wait 2 frames. And then for the section that it's applying the drag, that's specified by that drag duration of 6. So for 6 more frames, it will gradually multiply down that velocity. And I find that this velocity multiplier is much more natural if we go with an aggressive value at the beginning to a much softer value at the end. We really need an aggressive value at the beginning so that this explosiveness is really exaggerated and it slows down really fast after those initial frames. So in order to vary this amount of velocity multiplication, we need to know what point in our drag time we're at. So I figure out the drag time by subtracting the active frame from the current frame. And then in our if statement, I'll check to see if the drag time is greater than the drag start, but if that drag time is less than the drag start plus the drag duration, to figure out if it's just in that range. And if the drag time is within this range, it'll run that bit of code within the curly braces there, and it'll determine the amount of velocity multiplication by remapping the drag time between this drag start and the drag start plus the drag duration. And these two values at the end of the fit specify the values at the start and end of that remap. And once we have that velocity multiplier figured out, I'm multiplying the x and z velocity by that, but I'm doing an additional check to see if y is greater than 0. That will allow us to apply the velocity multiplier if it's going upwards, but if it's falling with gravity, then we're not going to apply that on the y dimension. And before we run the flipbook of this version of the sim, I'm just going to increase my gravity a bit. One way that I like to increase parameters is just by adding multipliers instead of directly changing the value. Just personal preference. So I'll just enter 2 times that default gravity value. And then we can run our flipbook. Now if we play back that flipbook, you can see sure enough we have some more explosive initial velocity. This does look a bit artificial and heavy-handed to me. I think our custom drag settings are just a bit too aggressive right now. You could make this a bit more natural, possibly by turning the drag duration down slightly or raising up those vmult values that are currently set to 0.7 and 0.97. If you bring those up closer to 1, then it won't reduce the velocity as much and could feel a bit more natural. And it can take some time to play around with these values to get them just right for your shot. Now we don't need this technique for the shot that we're working on in this class, but I have found it to be incredibly helpful for all of the explosion scenarios that I've been working with in production.